We're now recording.
Nice. Okay. I'm gonna share my screen. And then hopefully I can get this speaker view to work. Let's see. Okay. Can you guys see just like Google Slides?
Yep.
Nice. Okay. Cool. Thank you all for coming. I appreciate you being willing to spend some of your Sunday afternoon with me talking about some of my experiences in open source and a project that I've built. So yeah, title of the talk: How to Open Source Lessons Learned from Building Tailwind-ppx. Let's get started. Okay, so my name's Dylan. I want to introduce myself and make sure you know why, hopefully why it's worth listening to me. But I'm a senior in CS. I've done a few internships at some of the companies listed on the right. I've worked on a few open source projects, both personally and for a few different organizations, like the Art Institute of Chicago, UChicago, Pritzker, which is their medical school. And this is not really related to talk, but I'm very interested in this intersection between policy and technology. And I haven't found all that many CS interested people that are also interested in this topic. But if you are, please let me know. That's just more of a plug. So why am I giving this talk? For a few reasons. I think that it's pretty apparent that U of I's undergrad curriculum is not always oriented to the reality of software development. And I think that it's open source really represents a lot of what academia doesn't, in that you need to collaborate. You don't want to redo algorithms or implementations that have already been done. You want to really use existing code to build up a better solution. I also feel that there aren't that many relatable examples of students finding success in open source. Hack Illinois is really great at introducing new students to open source, but most projects that I've seen both are born at and die at Hack Illinois. And it's I haven't seen a lot of students carry on their projects and push it out to anyone besides their friends, and really grow their projects to any sort of effective, popular project. But the caveat is that open source, it can be immensely fruitful, both for you as a student and as a software developer that wants to contribute, grow your skills and communicate, technical and communication. But open source is also an immensely fruitful thing for the rest of the world, because open source represents a lot of the sort of ideal values that we want to have as people. Like I've contributed and communicated with people from all over the world, and just the very premise of open source as creating software for software's sake, not for a profit per se. I just think that's very admirable, and more people, open source benefits from having more people in it. So my goal for this talk is that you leave with a better understanding of how you can ideate, implement, and popularize your open source projects, because I'm sure that you guys have ideas that you maybe haven't pursued yet. So hopefully this talk gives you an example that you can reference when you start your projects. Okay, so what the heck is tailwind-ppx? It's in the title. It's the name of the project that has been moderately successful for me. I'm going to read you the definition, but we're going to get into what each part means. So tailwind-ppx is a reason/OCaml Pre-Processor extension that validates your Tailwind classes at compile time. Now we're going to get into everything of what that means. Here's just a demo just to set the stage. So on the left side, you have some Reason code. Reason is just a programming language. You can think about it as a JavaScript-like syntax with a much better type system. And you write React code. If well, you don't really need to know what that means, but it's the code on the left is Reason. And on the right side, you see the compiler that will recompile when I save the file. So as you can see, I'm writing in, after this class name, I'm writing in this funky syntax with TW, and then I write FLX. And you'll notice that my IDE throws an error saying that we can't find FLX. Did you mean flex? The Tailwind-ppx is the sort of tool that gives you this this compiler error if you've misspelled a class. That's just the premise. It's just more of a, you can think about it as a compiler plugin that throws some errors. So the outline of this talk. So first, I'm going to get into the motivation for tailwind-ppx, how I conceived of the idea, and why I thought it'd be useful for people. I'll go into a little bit of the technical details of the project, because after all, this is an ACM group, and I think it's important to have some technical discussions about the project. And then I will end by talking about some high-level non-technical learnings from my work in open source, and then I'll leave some time for Q&A. And please, if there's this presentation, we do have a small group, which is a benefit. Feel free after, before I progress to another slide, you can just interrupt me if you have any questions, and I really want to encourage that. I can't see the chat, so I mean, Reed, if you want to read if anyone has any questions, you can just read them to me. Thanks.
Sure.
So first, some motivation. So why is this project? Why was it born? Why is it worth working on? So the problem. I began to use Reason during one of my internships, and I was using it to write front-end code. Again, Reason is sort of an alternative to JavaScript that gives you a much better type system. And if you've worked with JavaScript, you'll understand why having a statically typed alternative could actually provide a lot of benefit. But all you need to know is that I was writing front-end code in Reason, and the process of my day-to-day really looked like I'd write some front-end code, I'd wait for it to compile, it would hot reload in the browser. So I mean, the browser would just reflect the changes pretty quickly. And then I would check if the CSS, that's just the styling language for the browser, if the CSS that I had chosen actually reflected the UI that I wanted. And the problem was that all the time I would often have typos. I would misspell a class name. I would use an invalid class name. And as you can see in the screenshot, you see flex, justify center. Each of these space separated identifiers are called classes, CSS classes. And it's really easy when you're typing out this long string to style the UI for you to have a typo. So for example, in this snippet, the typo is right here. There's no dash between M and 2. And without a PPX, without my PPX, without another indication that you have misspelled something, you won't know at the earliest until you check the browser and realize that no margin was applied. M2 is for margin of 2. So sometimes typos would make it into my pull requests. As an intern, this is kind of an embarrassing thing. But even my reviewers would sometimes overlook the typos, and they'd make it into the main code base. And so this was a problem. As you can see, this is just a string literal. There's no way of checking if you've made any typos. So I was thinking, like, wouldn't it be nice to just know about our typos when we compile? So like when we save the file, wouldn't it be awesome if there was a way to just say, you've made a typo, and I don't have to go to the browser. I just know in my editor if I've made a typo in the classes. So let's take a step back. I'm just going to quickly give an intro to Reason. Again, that's the language that I was writing front-end code in, and it's the language the PPX is written in and written for. So Reason is a programming language built by Jordan Walk, who's the founder of React. It's a popular UI framework. You can think of it as a JavaScript-like syntax for OCaml. So under the hood, the compiler, the type system is really just OCaml, which is a functional programming language that's been around for 20 years or so, mostly used in academic environments, but some companies do use it, notably Jane Street. Reason, the benefit of Reason is that there's two compilation targets. One of them is native executables via the OCaml compiler, or, and this is what allows you to write front-end code in it, Reason can compile the JavaScript through a compiler that Bloomberg actually wrote initially. And here's just, in this screenshot is directly from the ReasonML docs, and it illustrates probably the primary benefit of Reason. So I'll quickly walk through this example. Reason, remember, it's statically typed. So in this case, we're just declaring a type of school person. A school person can either be a teacher, a director, or a student. If it's a student, it has a name, so you associate a string value with that type. We also are defining a function called greeting. Greeting takes in one argument, which is person, and then we perform what's called a switch, a pattern match on that person. And we can basically, this is saying, this is a way of expressing, we want to say if the person is this value, perform this action effectively. So if it's a teacher, we're going to return from this function, hey professor. There's no return statements. Reason just in functions returns whatever the last expression is. So you have switch. If it's a teacher, you return hey professor, director, so forth. Now, if it's a student, remember there's a string, a name associated with that type. So if that string happens to be Richard, then we do this specific still here Ricky. Otherwise, we sort of destructure that string. We get access, we extract it with any other name, and then we can use it in this sort of programmatic way to generate a new output. So Reason lets you write simple, fast, quality, type safe code for either ecosystem, JavaScript or OCaml. I hope that makes sense, but again, you just need to know the basics of the language. So what are preprocessor extensions? Remember, tailwind-ppx is a preprocessor extension for Reason / OCaml because they're kind of the same language in many ways. So remember, Reason's built on OCaml, so we get access to its compiler, all of its idiosyncrasies, all of its benefits. And one of those benefits is this notion of a PPX, which is sort of like a macro, but effectively a PPX is just a program that translates an abstract syntax tree to another possibly modified abstract syntax tree. It's just a program that, given an AST, it runs over all the nodes, maybe changes some based on certain conditions that you can specify, and it'll output a new AST. And that AST will be the one that is compiled to the native executable or to the JavaScript. So I just kind of screenshotted, this is not a Reason AST, this is just a JavaScript AST, but it functions for the purposes of this explanation. If your code is var x equals 3, you'll get an abstract syntax tree, an abstract syntax tree is just a way of representing the structure of the program in this formal way. You have this top level program node, but what's really important is that you have the variable declaration and then you see this literal. That's what's saying, okay, x gets the value of 3. And a PPX, if you wanted to write a PPX for JavaScript, not that you could say, anywhere in my AST, I want to replace the value of 3 with 5. Now, I don't know why you would do that, but it's possible in this PPX ecosystem. So you'll basically the function will run over all these nodes, and then it'll translate the AST and just replace all the 3s with 5s. You'll notice that nothing else in the AST changes, but we can modify the value. And you can think about, we can do all sorts of interesting things by just running over the AST. And it's up to us how we want to replace nodes, if we want to replace nodes. So yeah, a PPX is important because it can throw compile time errors. If you can think about writing code in Reason, that string that I showed you with all the class names, that's just an AST node. That's just a string literal. If we were to indicate that at every one of these particular string literals, we could perform some action. And if a condition is not met, we can throw an error, and that error will point exactly to that string. And in the context of writing CSS classes and Reason code, we would prefer to be notified of these typos at compile time. So a PPX is exactly the faculty we need to have these high-level errors and these specific errors that really will improve our workflow as a front-end developer. And we want precise error messages. And PPXs are really common. It's not some esoteric construct that only a few people use. It's a very popular tool and benefit of using OCaml. If you're familiar with GraphQL, it's effectively a SQL-like language for APIs and data used on the front end, but people typically write GraphQL queries by just wrapping them in string literals. What Reason allows you to do is if you write a GraphQL query, you can verify that that query is type safe at compile time. You know, the PPX will be aware of your GraphQL specification. It'll know what the types are, and it can say, oh, this type is misspelled. That type is not present on current user. So again, you can imagine all the sorts of things you can do with PPXs. And yeah, GraphQL PPX happens to be one of the more popular ones. All right, so this is the last slide in the motivation section. I'm going to quickly talk about the timeline of how this idea was conceived, what the development looked like. So end to end, it's been almost a year since I first, well, I didn't have the idea, but since I first thought about building this tool. So in December of 2019, I got the idea from what would be my future boss at one of my internships. He floated this idea of a PPX for TailwindCSS, and I'll get into what Tailwind is a little bit, but it's just the CSS framework that actually writes those classes for you. Just hold that thought. But January, I started the internship, and by April, after COVID had hit, I started working full time on this project. Peter, as the CTO, and a few of the other engineers just encouraged me. COVID is making it difficult to work productively together. So why don't you work on this open source project that would be extremely beneficial for us as a company, but also the wider Reason ecosystem? Because after all, it is a pretty new language. So there's a lot of work to be done. By the end of April, I released the initial version, and this was a screenshot from a message I sent in the Reason Discord server announcing that the initial version is ready for people to test. By June or July, can't remember when, I reached 100 stars on the project. And by where we're at today, I've had 11 external contributors, 49 outside PRs, and we're now at 124 stars and counting on all of this. So by far my most successful open source project. Does anybody have any questions just about the motivation? Are we clear on why this project is useful and just how it was conceived? Cool. Okay, I'll press forward. Please stop me if you do have questions. So let's give a technical overview of the project and just talk about how I built this thing. So remember, hold the code. Just listen to me for a hot second. A PPX, remember, is a program that converts an abstract syntax tree to an abstract syntax tree. So at a high level, the PPX needs a function. That function will effectively take in an AST node, and the function will need to return an AST node, which will just be a sort of a one-to-one replacement as you recurse over this AST. You'll just repeatedly run that function for every node. In the code snippet, I'm going to walk through it line by line. So line 7 is where we're declaring the function. Remember, the name of the function is expr. It takes in 2 arguments, the important one being the second argument e, which more or less represents the AST node. We're going to switch on the type of that node. And if the node type is a PPX, this PEXP extension, if the node type is PPX and the PPX is tailwind-ppx, TW, remember, there can be multiple PPXs. So we want to specify like only run this validation if we're at the tailwind-ppx. We unpack it by just, there's a lot of boilerplate effectively. But eventually we'll pull out the location as a variable. And after unwrapping, we'll pull out the class names, which is just that string that we saw earlier, which has like flex, M2, background. That's the string that we're going to be pulling out and naming it class names. We'll perform some validation logic. So after this arrow is where we execute the validation logic. And then, and this is the important part, line 30 will return a new AST node. So you can say, we're returning a constant expression, and then we'll say construct the string literal that we want to replace the PPX node with. So, we have a PPX node. If we don't replace it, then there'll be some runtime errors because technically PPXs aren't even valid. So we need to replace it with valid language constructs, valid AST nodes. So we're going to have the PPX and we just replace it with a string literal. So then, once we replace it with a string literal, we'll be able to run the program. And line 31, that's basically saying if for any other AST node, that's this underscore, I don't know what it's called, but for any other AST node, we just run the default mapper, which is more or less just saying don't do anything, just leave the AST node where it is for anything besides the PPX node. So let's talk, now we're going to get into the validation logic. That's these 27 through 29. Obviously there's more lines, but let's talk about the validation logic. As input, I don't know why there's, yeah, okay. Okay, sorry. As input, we have a TailwindCSS file. If you haven't seen CSS before, it's okay. Just remember CSS is the styling language for the browser. It's, it's how everything doesn't look so crappy. This CSS file can define various class names. So if you see a dot identifier, that's defining a CSS class. And a class allows you to group similar styles together. So if we wanted to provide a shorthand for padding, it's just a way of adding spacing. We can say py2 is the class name, and then we can give a list of one or more styles that when we use py2, it'll apply all of the styles in the class. So it's just basic. I mean, it's basically like it's a variable in many ways because you're going to be reusing it throughout your UI code. But this is the CSS class, and you can have lots of them. TailwindCSS gives you all of these classes. So as input, we take in a CSS file. We also take in our input program. That's the reason code that we're writing. So in this case, the PPX syntax is this bracket % name of the PPX, TW, and then a string, and then finally a bracket. We take in both of these things, and we're going to output potentially 0 or 1 compiler errors. So in this case, it says class name not found M2. So it analyzed the string inside here and said, okay, M2 is not present in this CSS file, but flex and py2 are present. Hope that makes sense. Now we're going to talk about the initial algorithm. This is my naive approach when I first started the project. Okay, so we're going to recurse over every node. If we're not in a PPX call, we'll just continue, right? We only want to do interesting stuff if we're in a PPX call. We want to first, parse the valid class names. Remember, all this is happening at every AST node. We want to parse the valid class names. In this case, we parse this CSS file and we get flex, flexrow, and py2. So the valid class names, there's 3 of them in this case. We need to be aware of all the class names available so that we can do the validation. So we have this list. Next, we want to validate the node. So remember, we have access to in the mapper, or sorry, in the code that I showed before. Remember how we destructured the AST node in order to pull out the value of this string, and we pull it out, and it's named class name string, and that's just a string that says flex py2 m2. So we just pull this out, and now once we have access to it, we can do some validation on that string. So we're going to split it by white space. And then once we split it, we get flex, py2, and m2. For the validation, we're going to iterate over that array and just check, is every element present in the valid class names? So we have valid class names on the left and the current class names of the node on the right. Flex, that's okay. That's present in our valid class names. py2 is also present. So that gets a smiley face. m2, however, is not present. So we're going to throw an error. And that's the extent of our validation. Remember, we had pulled out the location data as well for the node. So when we throw the compiler error, all we need to do is say the error happened at this line and column number, which we have access to. And then we just say, oh, the offending string is M2. So we can give the developer precise information on how to resolve their error. And then every single time we change some code, we'll repeat that algorithm, because the PPX runs on every single compilation. So in summary, We recurse on every node. If we're not in a call, we continue. Otherwise, we parse at every node, we parse the class names, we do some validation on the current node, and then we repeat the algorithm for every code change. There's just a few problems. And these are real GitHub issues that were raised early on in the project. Within 10 days of releasing, there were like, I'd opened one, sure, but there were a few people pointing out that the performance of the PPX was actually very poor. One user said that the PPX was killing his CPU. And another user, and this one is the most telling, said that the PPX just completely slowed down the compilation process. With the PPX, you can see it compiled in 3.42 seconds. Without it, 0.33. So that's almost a factor of 10 difference. And he pointed out that he only used, his CSS file only had 8 different class names, or it was a very, very small example, but still absolutely killing the performance. Okay, so discussion time. And this is, I really want to hear some input from the audience. I want to get your algorithmic juices flowing. This is not a technical interview, so you don't have to worry about passing, but I'm really curious to see, and I reposted the naive algorithm. Where do you think the inefficiencies are? Think about the runtime. I'm really curious to hear where you think we could improve this algorithm and resolve some of the performance issues.
So is the issue is that like every single time you add something new, it runs through the entire file again instead of just like looking at the new thing that you add?
So that's a very good point. You're actually you're picking the hard optimization, and that is totally something that we could do. That optimization, at least the way I'm thinking about it, would require you to just be able to like diff the CSS files. But that's a good observation, and that's not even one of the easy optimizations that I thought of. But that's certainly a good thought, and that would affect the performance in a good way. I'll write that down so that I can implement it later on. That was a good thought. Any other takers?
Is it possible that we could like just search over less nodes? I'm not sure like how we would.
Yeah, no. So that it's a good question without knowing just how PPXs work. As far as I know, a PPX necessarily has to look at every node. So you can't sort of split up the PPX nodes from the non-PPX nodes. So at minimum, the PPX has to run over every node.
Okay.
Okay. Anyone else? At least one. There's only a few people here, so at least just give one. Everyone can give at least one thought.
Well, it seems like the easy thing is not to parse the class names every time.
Yeah.
Right.
Exactly.
I mean,
that's the first thing. There's a few other small. There's one other really notable improvement, and it's important to remember what the types were of how we were storing everything, especially and hint is it's in the validation step. What could be slow in the validation step? Shaw, if you're still here, I don't mean to put you on the spot. It's okay.
Well, I mean, if you say it's a validate step, it'd probably have to be B, right? Because I don't think splitting could be improved anymore, but still trying to think about what could be made better there.
Yeah, no, you're totally right. The splitting that has its base runtime. That's not the algorithm that I'm implementing per se, but you're right in the sort of the scope of where the problem lies. So let's talk about it, okay? So as Reed pointed out, the biggest bottleneck is that we're parsing the CSS file every single time. This is just not intelligent. So the solution to this, the easy solution, is to store the valid class names in a mutable variable after we get to the first node. So you could have multiple PPX nodes throughout your project. After you get to the first one, you can parse the file. And because The PPX, you can think about it as sort of like an executable. It just runs over every node. You can store the valid names in a local variable, and then every single time you get to a new node, just reference that variable. And you won't have to parse again. You just check if it's been, if it has a value. If it does, you have already parsed. And you can reuse that throughout the execution. Now the validation lookup. Remember, the type of valid class names was an array. So every single time we want to do the check of if a class name in a node is present, is valid, that's an O of n check because we have to scan the valid class names array. So the easy solution is to use a hash set for the valid class names. And then we have an O of 1 check for the inclusion of a class name. So we can do validation effectively O of 1 time, at least that part. Now the final performance bottleneck, and remember, these first two were implemented very quickly, very early on, and that solved most of the performance issues. This last one is not easy to come up with, but we have to think about if the Tailwind CSS file doesn't change, we have to answer the question: should we even still be parsing it? If it doesn't change, if the user doesn't, if no new class names are added to that CSS file, the valid class names it remains the same, but we still parse it after that first PPX node with this solution. So the way that we solve that, I need to remove. Okay, sorry. The way that we solve that is by caching locally in some files, in a file, the valid class names. And reason/OCaml is nice in that you have this set of the valid class names, and using a built-in module, you can directly store that set, that data structure in a file and just read from it directly, and it'll parse it it'll encode and decode the set, that data structure, as long as you have a file, a local file. So you cache the valid class names, but that's not enough because you need to know the associated CSS file for those valid class names. Otherwise, you have no way of knowing if the CSS file has changed. I guess there might be some more clever ways, but you also want to store a hash of the CSS file that generated those valid class names. And at the start of every run, PPX run, you'll just hash the current CSS file and compare that hash to the old CSS file. If they're different, you need to reparse. So this condensed algorithm v2, at the start of the run, will compare the hashed CSS file to the current one. If they're equal, the valid class names haven't changed, so we continue with the algorithm. If they're unequal, we need to run a new parse, and then we'll rehash and recache everything. We'll read the encoded class names directly into a set, again, using a built-in module that just speeds up things ever so slightly because you don't have to, read the string in, the string literal in, parse it, and whatnot. We just store it directly into a set when we pull it out of the file. Then we recurse every node. Again, if we're not in a PPX call, we continue. Otherwise, we validate. So we extract the names from the class names from the current AST node. We verify that each constituent class is present in the valid class name set. And then we repeat the algorithm on every code change. Any questions? Does everyone understand both the naive algorithm, how we improved it? Are there any questions? Any suggestions for, am I doing anything that's like, or are we as maintainers not doing, doing something that is totally malarkey? Is there a better way? Is there a better algorithm? Any questions? Just any thoughts? Silence. I must have done a good job. Not in the presentation necessarily, but the algorithm might be better than I expected. Okay. Well, there's also gonna be time for questions at the end, so please, I need at least one question from somebody. Okay. So let's forget about the technical stuff. Technical details are important as a computer science major, but communication skills and non-technical insights and abilities are also very important too. So let's talk just about the non-technical things I did for this project and some of the learnings I have, especially as you think about what open source projects you might want to work on, how you even get started with an open source project and how you grow it to those, initial users and whatnot. But let me just share, I'd like to share some learnings with all of you. All right, so, the rough outline is I'll talk about the importance of validating, getting idea validation before you start coding. And the second, relentlessly driving adoption for your open source project. And then the third, I'd be remiss if I didn't end by talking about the importance of people not named yourself for your project. So first, the importance of validating your idea. So recall this guy named Peter, this abstract guy named Peter, was actually the one who gave me the initial idea. And even he did not get it, even he did not come up with it on his own. As you can see in these screenshots, from October 2019, November 2019, in the Reason community, this type of project, this PPX for Tailwind development was already in discussion. And somebody, Gabriel, who actually became a contributor to my project, he had thrown together a very minimal Tailwind PPX of his own. But it didn't work very well. He didn't have much time to work on it. But the important thing to note is that the interest was there. People were working on it. People were talking about it. And so that gave me enough assurance that people would actually use it, that greater than one people would use it. And finally, and this is not always the case with people, I got paid to work on this project full time. It's very unlikely that, it's more unlikely than not that I've, in the timeline that I did, within a month, gotten a working version, been able to quickly respond to issues. If I wasn't working on the project full time, that would have been much more difficult. Now, I'm not saying you have to get paid, but especially early on in the open source project, it's very important to respond to issues quickly, to iterate and respond to the community. And you don't have to be getting paid to do that, but you do need to be attentive. Getting paid just happened to be, it was just nice to be able to work on that full time. Now, the second important point is that you need to, at the start, relentlessly drive your adoption. And there's a few different components to this, but first you have to be ready when you launch the project. I'm reposting the screenshot from the Reason Discord server below, but April 23rd is when I announced it. I also made some posts on the Reason Reddit channel. I didn't include it here, but I think announced in the OCaml user group, because there's some overlap there and people might be interested. And then Hacker News didn't go that great. There's only 2 points or whatever, but it's about getting yourself out there. It's about putting your project out there earlier rather than later. And for this to work, you have to be ready a day or two. You want to coordinate these launches and announcements all at once in the same way that if you're working at a company, for example, that you'd want to have your marketing ready when you release the product, for example. So the second component of this, like I mentioned earlier, is you need to respond to issues quickly and thoughtfully. Now, I pulled one example of, this is the same guy, T. Koopman. He's fairly active on my project, but he was the first one to open an issue that was not named me. I mean, there was a lot. I had opened a lot of issues privately, but he was the first non-Dylan user to open an issue. And this is not, and I'm not doing this to prop myself up, but I made it a point to respond to him quickly and also give him a very detailed example. He was asking if it's possible to do this one thing with the PPX, and I told him basically no, but here's the exact code that you'll need to perform and do what you're trying to do. And then that issue was quickly closed, and I added that to the documentation in the README because it was a popular question. So early on, respond to issues quickly and thoughtfully. Open source is less about code than it is about marketing. At the end of the day, your project is only as good as your README, as the way that you communicate to users of your project. It's open source. The value of open source and the way that you grow your projects is not in the technical part per se. Obviously, you want to have a good idea, but in order to drive adoption, you need these non-technical skills. And if you don't do these things, it's very likely that your early users, who are your most important users, will churn and not stick with the project. Because open source, especially early on, projects, if they're not working right out of the box, which they inevitably aren't, it'll be hard to convince people to continue to use your project. So please, relentlessly drive your adoption. And finally, you need to have a good README. This GIF might be a little bit overwhelming, but as you can see, I have a table of contents, a screenshot seeing exactly what the project does, because a lot of the times people that are coming to your GitHub won't even know what reason is. They likely won't even know what a PPX is. So it's more important to talk and give, I gave a screenshot saying exactly what this does for you. Then the table of contents, having that laid out, saying exactly what the features, offerings of your project are, installation instructions, FAQs, and you can't forget the contributors as well. Having a good README is probably the most important thing in open source, like by far, or at least good documentation, like a separate documentation site. And yeah, read that again. Please have a good README. Now, finally, and this is most important in our current, I think, world and political climate, you need, as an open source contributor and maintainer, you need to bring people together. You need to be human. You need to be kind. As I mentioned earlier, I've had 11 external contributors, 49 outside PRs, 124 stars. Open source, at the end of the day, it comes down to relationships. As you can see, this screenshot, I made sure in my README to acknowledge everyone that I contributed to my project, be it code or raising an issue, providing ideas through Discord, just messaging me. All these people have had a role in growing the PPX to where it's at now. And if you don't acknowledge these people, if you don't really encourage the community to open PRs, to raise issues, you don't interact with them in a kind way, if you respond antagonistically to issues, for example, you won't be able to grow your project. And the caching scheme that I talked about earlier, where we store the hash of the tailwind-CSS file, where we store the set in a file, the set of valid class names, that whole sort of feature was contributed by Corentin. He is actually, he has write access to the repository. He came along later on, about 3 or 4 weeks into the project, and really took over. And because he was excited about it, he wanted to learn about PPXs and stuff. And I really encouraged him. And eventually now, we've been pushing a lot of the changes. So it's not even really a solo project anymore. It never really was a solo project. So it really comes down to relationships. Open source is necessarily a worldwide venture. I doubt, I don't know how many countries are represented here, but it's probably like at least 3 or 4. And so really be kind to one another, drive, forge good relationships, especially with the community. So the biggest takeaway is that the first 100 stars of your project will be the most difficult, but you can certainly do it. And I would hope that some of these lessons, understanding how I got motivated to do this project, how I thought about why it would be useful to people, all of that stuff is really important. And remember, the code is always secondary. It's non-technical things that really make or break a project, but you can all do it. And if you need help, I'd be happy to be a resource for you. So stay safe, stay masked. COVID numbers are rising quickly in pretty much everywhere in the US. So please stay safe. And thank you all so much for coming. I really appreciate you being willing to listen to me ramble. And if there's any questions, I would be happy to hear them out.
Thanks for presenting. You did a really good job.
Thank you.
Questions.
Yeah.
Have you done other projects before this project that prepared you for this project?
I had dabbled a little bit in open source. This was not my first. This was not my first time open sourcing a repository. Like I had worked. I've always been interested in open source. I attended Hack Illinois a few times, but this was the first time that I changed my approach. For the other projects, I started by just, doing tons and tons of coding. I didn't really look to see if the project that I was building would be useful. I didn't really communicate with anyone in the outside world. It was more just an idea I had. So I worked on a few projects, not many, but tailwind-ppx was the first time that I changed my approach and focused more on, the non-technical side, gaining the, the requisite information, gaining context around the use case, immersing myself in the Reason community through Discord, through Reddit, through GitHub. And it also helped that I was working at a startup at that time that offered me some guidance and quick feedback. But the short answer is that I had worked on some projects, but I didn't have a good approach when I was working on them.
How did you know to change your approach this time around? Was it just something that like happened, or?
I think it was after I had done, after I was in the internship, at that internship, we used a lot of open source tools, and the themes that I had noticed about those tools, when you go to the documentation, when you go to the README, the thing that the most popular tools have in common is that they have great documentation. They have lots of people contributing. It's not usually one or two core maintainers. There's a big community of people contributing. And also there's tons of information in the README about the context for the project, at least from what I saw. Like there would be maybe a comparison of tools that didn't work in the past. There would be discussion of why a certain, trend in tech necessitated the project. And so just reading that and seeing that that these, really popular projects focused less on the technical details. Even if you weren't a developer, you could probably reasonably understand what the project was trying to do. That gave me a bit of inspiration and made me think, oh, I mean, this is going to be a technical project. I'm going to have to learn about OCaml and Reason, which are already pretty niche languages. But first and foremost, I need to understand the use case for what I'm building. And that use case is improving the workflow of front-end developers at the end of the day. So yeah, it shifted because of probably viewing open source successful projects and just comparing my prior failures to grow my projects compared to these really popular ones.
Cool. What advice would you give to someone like me who's like a beginner who wants to get involved in open source but like doesn't know how?
Yeah, I think so the biggest thing for me is that with Reason, the programming language, Reason happened to be a new language. It's only been around for 2 or 3 years. And so its infancy sort of left a void, or rather it left some opportunity for a lot of people to come in and add new tooling, add new libraries. So even in the Reason community, there's still tons of work to be done by mostly adding new libraries or thinking about how to use the compiler in this unique way, because I haven't found another programming language that allows you to do a similar compiler plugin of sorts. But for newcomers, I would find a community, probably if it's early, if it's a newer community, if it's a technology that you're interested in, like a programming language or a framework of sorts. The newer the technology, the more opportunity you will have to be a contributor. And if that's something that you want to do, I think it's going to be hard to open source something popular in Java or Python or even JavaScript at this point. But there's new languages coming around all the time. There's new technologies. I think the biggest thing, just follow the trends. Be up to date on what is new. And if something piques your interest, don't just be a passive observer. If you want to contribute and you have a motivation to contribute, try to immerse yourself in the community. Most of these groups have Slacks, Discords, or other sort of user groups. Immerse yourself, understand what people need, and then you'll be able to know, you'll be able to find out what to code. But I would, in terms of actionable feedback, I would escape academia because they teach you C++ and Java and Python, which are languages that open source is going to be extremely hard to do right. And just spend some time not in school, just like looking at new tech and seeing what interests you. And I'm sure you'll be able to find something to contribute to. Message me if I'm on Slack as well. I'm also on Discord, but more frequently on Slack. And I'd be happy if there's something that interests you, like to help you just come up with the idea, because it's very contextual. It's hard to give broad sweeping advice, but I hope that there was some helpful things in there.
Yeah, there was. Thank you.
Yeah, sure. Is it Alex?
Yeah.
Okay. Thank you for the questions and thank you for coming. I really do appreciate your time.
Yeah, I don't have any questions, but I thought it was really enlightening, I guess, like to hear about a lot of this kind of stuff. So I appreciate it.
Cool. Thanks, Colin.
One question. How much time did you put into, like when you said full-time working on this open source project, how long was that, or like how much time did you spend every day?
Yeah. So I started the project in like early April. I think it probably took me 2 weeks working full time, which means probably 30 to 40 hours a week. 30 to 40 hours a week. I mean, COVID, that was the start of COVID. So take those hours with a grain of salt, because it was a stressful time for everybody, but probably no more than 30 to 40 hours for about 2 weeks to get the project off the ground to a V1. And then I had about a month left in my internship. And so I probably worked like 20-ish, 25 hours a week for the next 3-ish weeks. And then I ended my internship. The project got to a much more stable spot. And then I just would respond, some weekends I would spend maybe like an hour or two looking at issues. But honestly, the time I've spent, it's only gone downhill. And that's for a couple of reasons. I think the project got a lot more stable. People joined in. I didn't have to contribute a lot of like the hard features. That was mostly other people adding pull requests for these like one-off things. And so in total, it's hard to put a specific hour amount on it, but I was probably working like full-time 30 to 40 hours for probably like 3 to 4 weeks or so. And then it just slowly waned. It slowly like declined after that. It's hard to say a specific time, but I definitely haven't been working like full-time on it for like many months. It was literally less than a month of really grueling work. That
makes sense. Yeah. I was just wondering because like, I feel like in a sense, that's sort of another like scary point, I guess, of like starting your own project. And it's that like, there's so much time that you have to spend into responding to people's issues, doing all the people outside interfacing stuff, as well as coding. And even on like research projects and like, I mostly look at like bioinformatics and like genome stuff, but like even there, people are making new assemblers and whatever, and like that's going on GitHub, but like those projects are being pretty much constantly maintained mostly by like the same person, while hundreds of issues are coming out a day or something like that, because other people are complaining and stuff. So I was wondering. That's cool.
Yeah, no, it's a really good point, Shaw. I think most of my time, I would say in the long run was like I can't tell you how much time I spent just nitpicking my own README and responding to issues. Like I had pretty lengthy discussions about the future of the PPX and what features I thought to prioritize. And we can look in the GitHub issues. There's long discussions. Discord, I spent quite a bit of time responding to people. So I would say like 50%, if not more, was doing the non-technical stuff. And so I would probably keep that in mind, that most of your time, like I got really good at Markdown through the project, like writing GitHub comments and READMEs and stuff. So expect a significant time commitment, but you're doing something right if you end up spending less time on it. And there's also like less people raising issues, and I'll support you along the way.
Yeah, cool.
All right, it is 4 o'clock, but I'm happy. I'll stick around if anyone wants to keep talking.
Yeah, well, yeah. I've not to belie the last point, but I do have some questions about the technical side.
Yeah.
So The main thing you talked about was validating the class names,
Mhm.
you know, checking the classes exist. Does it do anything
Yeah.
else?
Let me, here, can you, I'll see if you guys can still see my screen. Tell me, can you see GitHub? Okay, I'll need to reshare then. Let's see. Okay, you should see it now. Okay.
Yes.
So I'll zoom in on these features. Okay. So in addition for checking for invalid class names, we check for duplicates, right? Because a style can only be applied once. So if there's duplicates, we raise an issue. We include documentation to keep your, or sorry, we included a feature to make sure that your CSS file is always in sync. So when you're running the compiler, if you change a CSS file, it will recompute the valid class names and stuff. So nothing will get out of sync. That's not as important. But we added, and this is a very JavaScript-y specific thing. The Tailwind CSS file gives you, it's like a 70,000 line file, and there's lots of class names, and you probably only use a small subset of those in your styles. So we included a way, through existing JavaScript plugins that will purge your unused class names based on what you use inside the PPX. So that file size the CSS file size will go down a lot. And this was the thing that I added that was really exciting. People using this project often add it on after they've already been writing code without the PPX. So like putting stuff just, sort of naked, if you will, inside of the class name string. So I wrote a script that will iterate, it'll recurse over all the project files and convert any uses of these into these, which is nice. And I guess the final thing is it offers suggestions. So like it does like a Levenstein distance thing. And if you're close with the spelling, it'll offer you what you probably meant, which is nice.
Nice. Yeah, that's cool. Okay. And then I have a broad question, which is, what are your thoughts on Reason
as a language?
Yes, compared to, I don't know if you have JavaScript experience or whatever.
Yeah, so I had, last summer is when I started learning React with JavaScript. Didn't really learn TypeScript, which is a popular alternative. Like, I'm gonna stop sharing because there's really no need. So the thing about JavaScript, once you write it, is that you notice the type system is really bad, and there's so many times you get into either null or undefined errors. Or, JavaScript, if you use a double equal sign, it'll say that the number 0 is equal to the string 0, or like you get into these really like weird cases, mostly due to the type system. And you also, because it's it's not immutable by default. If you pass in stuff to functions and you're not careful, you could change, you could just get some weird cases where the value gets changed when you're not expecting it. But Reason, because it's everything that JavaScript is not, it's like a static type system. You get really powerful pattern matching constructs, which in React is really helpful because you can think about, if you have a switch statement, you can say just like render this UI or render this UI or render this UI, versus doing like if, else if, else if, else if, which is a lot more clunky. So it's really nice for writing front end code. So there's like Reason for the front end, I would say should be the choice over TypeScript. If you're writing front end code for the web, do Reason. I would recommend it. You can also write Reason for native, which is like the way you sort of like the OCaml way of writing it, because you compile the native executables versus JavaScript. If you're doing that, I mean, there's probably better languages. Like Jane Street uses OCaml for a lot of their systems. And if you're going to use Reason native, I'd probably just go with OCaml. I mean, there should be smooth interop between those, but like Reason native is a lot less used than this use case for Reason in the browser. So the community is much bigger here versus here. So I would say it's a good language for writing web interface stuff. And I would say that you should use that language, as long as JavaScript is the base for everything. But with WebAssembly, we may, get some new paradigms, but use Reason if you want to write a UI.
Cool, thanks.
Thanks for the question. It's good. It's good. Anyone else have any questions? Cool. All right. Well, thank you all for coming. I really do appreciate your time. Have a great rest of your semester and Thanksgiving break, and travel safely. We'll be here in SIGPlan almost every week, and Reed is normally the presenter, but
But thank you for presenting.
Thank you.
Thanks everyone. If I leave Reed, will the